Hello everyone. Welcome to today's topic of soybeans, biostimulants, and inoculants. I'm sure all of you know what soybeans are, and some of you may know a little bit about inoculants, but you may not know as much about biostimulants or how biostimulants differ from inoculants. Most of us who have worked with soybeans over the past 50 years are probably familiar with inoculants. But in case there's someone who's not quite sure what the difference is between an inoculant and a biostimulant, let's look at some of these definitions. If we look at the definition of an inoculant, it's a live bacteria or fungi spores that are intentionally added to plants. In the past, there were really only one class of inoculant, and those were the ones that had the symbiotic relationships with plants for fixing nitrogen. In soybeans, this would be the Bradyrhizobia bacteria. Today, there are actually three really main classes of inoculants. In addition to those that are symbiotic, we have those that are antagonistic with the plant pests. And these are the ones that grow with the roots, and they protect the host plant from infection from nematodes or from diseases. And a couple examples of these would be things like Votivo that just recently came out on the market. Saber X is another one that's out there that's a red inoculant that helps protect against fungi. And our third main class are those that increase nutrient uptake. And these are bacteria or fungi that colonize the roots, but they also alter the rhizosphere around the roots and make nutrients more readily available for plant roots to take up to help the plant grow very early in its life stage. We've heard about the inoculants, but what are biostimulants? If we look at the definition of a biostimulant, it's a substance from one biological system that elicits a positive growth response in a different organism. It could be a hormone, an extract, a protein, or simply a single molecule. One example of this would be a product such as Vitazyme. And Vitazyme is one of these things that has about 13 different active ingredients in it that are supposed to all serve as biostimulants. It's not the only thing out there, but it is one example of a biostimulant. If we look at what's on the market today, there's a lot of products that are inoculants or biostimulants, and sometimes there's quite a few that are actually hybrids or combinations of both a biostimulant and an inoculant. Examples of this would be such as Optimize 400, Tag Team, or Vault HP, just to name a few of the many products that are out there that would be considered hybrid products that are both biostimulant and inoculant. Some of you may be wondering just how does an inoculant compare with a biostimulant in their effects upon soybean growth? Are there differences in growth, the nodules that are produced, the root sizes, yields? And as a soybean producer, these are very important things to have answered, especially the very last one, which is yield. In a 2011 trial that was held here in Lancaster County, Nebraska, we had a number of products that we put into classes. These classes were products that had an inoculant in them, products that had biostimulants only, or did not have an inoculant or a biostimulant in. This would be like the untreated check, things that just had a fungicide in them. And if we look at these things, we saw some very different patterns emerge. If we look at what we have here on the screen, we have those that had an inoculant in are the yellow bars. Those that had the biostimulant are the blue bars, and those that had neither product are the green bars. If we look at our nodules per plant, it was kind of surprising to us to find that our biostimulant-only products actually had more nodules on the roots than did the inoculant products, which had more than did the check-type products. However, when we looked at the weight of 1,000 nodules, we saw the inoculants had larger nodules. If we look at the nodule weight versus the root weight, we saw inoculants and biostimulants were somewhat similar and were both, shall we say, significantly more advanced in that regard than was the check or the fungicide-only treatments. When we look at the mean weight of these types of products on the roots and the nodules, we see the biostimulants had the largest amount of root mass, followed by those that had inoculant in the products, in the treatments, and followed then with those that had no inoculants or stimulants. The nodules on the roots, which were weighed separately from the roots, followed that same pattern. What is of most interest is what we saw with these treatments for yield. Our two on the left on this graph, which is the untreated, and the Trilix 2000, which is the fungicide only, actually had the two lowest yields in this particular experiment. If we look at the next three right next to it, the BioForge, the Heads Up, the Optimize, and if we include the ST822, those were all substantially more, 2 to 3 bushels more than the check, and these were all biostimulant type products. And as you can see, there is some variation in some of the others that were biostimulant as well as inoculants in some of the other bars to the right of this graph. But as you can see, every particular product that we looked at that was a biostimulant or an inoculant gave a slight increase to a 2 to 3 bushel increase over untreated soybeans or even just fungicide only. Well, that was one experiment, but one experiment may not capture what we've done over the past several years. So what have we found in the past several years of experimentation? What did we find in regards to timing of the applications and the economics of such applications? Another question that we'll talk about just slightly is, do these different biostimulants elicit different responses in the soybeans? One of the things we've noticed over the years is that our greatest responses, both in terms of increases in yields and net economics, when it comes to biostimulant applications to soybeans, have been noted from those that have gone on as seed treatments. The application cost is less, and the amount of product needed per acre is less. It also gives the plants the greatest time to react to a biostimulant and have more growth and potential yield. We have looked at a number of foliar experiments on soybeans which have involved biostimulants over the past 5 years, and we've seen some interesting results from irrigated fields. I'm going to share one such experiment with you today where we had 2 applications of these biostimulants, and in this situation we had 6 different treatments. As we said, they went on twice. The first one went on before the herbicide application, and the second application went on after the herbicide application. It was very interesting to us. As we looked at this, we saw significant differences in pod set in mid-August. When we looked at the pods per plant in this particular experiment, we were somewhat surprised to see the untreated check had the most pods per plant. It was significantly much more so than some of our other treatments that we had that were almost 10 pods a plant less. But when we looked at the yields of these soybeans, we saw basically all the treatments gave us about the same yield. Not much difference up or down compared to the check, and this was very similar to what we've seen with almost all our foliar applications we've made in mid-season or at first bloom to soybeans over the past 5 years. Not a great difference in the amount of yield increase compared to untreated soybeans. One of the things we want to also talk about is when we've compared some of our biostimulants and inoculant seed treatments in 2010, we did want to point out that 2010 was kind of noted for a cool July weather with high temperatures in August. And we bring this out to show you some of the results we got under those situations in 2010. In this particular experiment, we had Optimized 400, which was a hybrid type product. It has both an inoculant and a biostimulant. We had Vault HP, which is primarily strictly an inoculant. We had Vitazyme, which is a stimulant, and we had the untreated check. In this particular graph in front of you, you'll see on the far right-hand side that on the 30th of August, the untreated check had 10.6 trifoliate nodes on the main stem. All the other treatments had 11, 12, as much as almost 13.8 trifoliate nodes compared to the untreated check. 3 more nodes at this time of year is very, very significant because it means a lot more chance for pods to set later on in the year. As we look at this experiment going into August, we see that trend continues, and even by the 9th of August, we're having 3 more trifoliate nodes on that main stem with the Optimized 400 versus the untreated check. Very, very highly significant statistically. And this continued on until we stopped sampling at the 19th of August, and we can see at this point in time we're still having 1.5 more nodes compared to the untreated check. All the treatments gave us a slight increase to a substantial increase in the number of nodes. Unfortunately, we're not harvesting nodes. So what did this do to the rest of the plant? In this graph, we see the numbers of pods we saw developing by the different treatments during the latter part of July and through basically 2/3 of the way of August. On the far right-hand bars are the untreated check. At the end of July, there really wasn't much difference between any of the treatments compared to the untreated check, although the optimized treatments did have a few more at that point in time. 10 days later, on the 9th of August, we have the check at about 73, we have the vault at about 70.5. That's not surprising. The vault is not a biostimulant, but the Vitazyme and the Optimize are biostimulant products. And if we look at those compared to the untreated check, we're seeing 90s for the Vitazymes versus 73.5 for the untreated. If we look at where we are, the Optimize, we're looking at 113 to 100.6, 25 to almost 35 pods a plant more. We are getting very excited about this. And even yet, 10 days later on the 19th of August, we're still seeing about 25 pods a plant more. We are very excited about this because this meant a great chance for increasing yields. In this graph, we see the numbers of pods that we saw developing by the different treatments during the latter part of July and through basically 2/3 of the way of August. On the far right-hand bars are the untreated check. At the end of July, there really wasn't much difference between any of the treatments compared to the untreated check, although the optimized treatments did have a few more at that point in time. 10 days later, on the 9th of August, we have the check at about 73. We have the vault at about 70.5. That's not surprising. The vault is not a biostimulant, but the Vitazyme and the Optimize are biostimulant products. And if we look at those compared to the untreated check, we're seeing 90s for the Vitazymes versus 73.5 for the untreated. If we look at where we are, the Optimize, we're looking at 113 to 100.6, 25 to almost 35 pods a plant more. We are getting very excited about this. And even yet, 10 days later on the 19th of August, we're still seeing about 25 pods a plant more. We are very excited about this because this meant a great chance for increasing yields. So, we were looking forward to harvest with great anticipation. We were looking forward to some big differences in yields and final pod counts. What were we going to see? I think one grower probably stated our observations at harvest most succinctly when he said disappointment. Because we were disappointed. Instead of big yields at big differences in yield, we saw everything was about the same. Basically, we're all lower 50s for the yields across the board. The pod numbers, which had been 100 to almost 115 for the Optimize, was now down to about 50. The untreated was about the same situation. In fact, all the treatments had about the same numbers of pods and the same number of bushels statistically. It all came way down, which made us wonder, why did this happen? And I think as growers, this is probably symptomatic of what happens sometimes with biostimulants. We think we have something great happening, but it's not consistent. And so we're taking this the next step further to find out, why are the results inconsistent, as noted by high levels of pods in one location associated with biostimulant, but lower than untreated soybeans in other locations? Is it the variety? Is it the herbicide? Is it fertility? Is it the weather? Lots of different factors need to be investigated. In 2011, we were able to do a side-by-side trial where we put the same seed treatments on two different varieties in the David City area of Nebraska. The blue bars are the mycogen variety. On the far right there is the untreated check. And as you can see, the ST822, the Optimize 400, the Vitazyme, they all resulted in increases in yields as biostimulants compared to this variety. However, the same seed treatments on the other variety, the Asgrow 2909, in this situation, did not give us the same results, even though these were side-by-side alternating strips of varieties across the field. The check was 46.1 for this one. In this situation, the Vitazyme actually yielded less than the check. The Optimize was slightly more, and the ST822 was very consistent of about 8 to 9/10 of a bushel more for both varieties. Obviously, there seems to be an interaction here of variety with biostimulant. If we look at the pod distribution at harvest for the Asgrow varieties, we saw something very interesting happening. At the 6th and 7th trifoliate node on the main stem, we saw significant differences happening at that point in time, where the check actually started having more pods per plant than did any of the biostimulant treatments. This was kind of unusual, we thought, and what could be causing this? Going back and looking at the data, this is where the plant was at, basically at this point in development when herbicides were applied. This may mean that there may be a herbicide interaction with this variety as well. When we looked at the pod distribution at harvest with the other variety, we did not see the same trend at all, but there we see basically all the biostimulant products were giving us more pods per plant at every node through the 7th node. One of the other things in 2011 that we learned through our experimentation was what happens with biostimulants applied at planting when they're liquid biostimulants versus seed treatments. And so we were able to do this as part of the Nebraska Soybean Management Field Days at 4 locations around the state. This gave us a chance to look at these products on 2 different varieties. And when it came to harvest, we saw some very interesting results. Unlike our previous data we have shown you where we're seeing slight increases for most of the biostimulants, almost every single variety and treatment resulted in a yield decrease in these experiments. Anywhere from sometimes as much as 4 bushel an acre decrease, sometimes just a slight decrease. There was one exception with one variety where looking at the low rate of GS48 gave us an increase, but the high rate of this product gave us a large decrease. This is very odd, and why is this happening? Why should all these biostimulants be giving us negative effects versus positive effects? One of the things we looked at in looking at the different field activities was what happened with herbicides. And this past year at the Soybean Management Field Days in Nebraska in 2011, they had as many as 2 to 3 different herbicide applications that went on these plants. And it was usually sometimes combinations of herbicides. So what can we learn from this, or what can we take from other crops? Because we have looked at herbicides and biostimulant interactions in other crops in Nebraska. The crop we're going to talk about is alfalfa, and we've looked at some of our net yield differences with what we're seeing with biostimulants compared to the untreated alfalfa. And here in this particular slide, we're seeing anywhere from 0.08 to basically 1/3 of a ton increase from a biostimulant. That's very, very good. In this particular experiment, we were also able to split the experiment in half, and so we had some treated with the herbicide and some treated without the herbicide. As we look at this, we see the red bars in this situation showing what happened with the yields of biostimulant alfalfa when treated with herbicides compared to untreated alfalfa that received herbicide-only treatment. And we can see in every situation where we had biostimulants, we had a negative effect in yield compared to untreated alfalfa. So to kind of sum up some of our experimental results we've had thus far, we seem to be seeing some interactions between soybean varieties and biostimulants. We see that not all the responses are the same and can vary by field. Why? Well, there may be a number of reasons. We do know these responses across the same variety can differ by field. Is this a function of the interaction with a herbicide, with the herbicides being different? Or is it another factor? Our trials for 2012 are investigating if the interactions are occurring between biostimulant-treated soybeans and herbicides, some of the things we will see today on the plot tours. The other thing that we all need to keep in the back of our mind is if biostimulants are increasing yield potential, we may need to be increasing our nutrients as well to realize this. On the chart here in front of you, I think we probably all know this. If we look at this, we know it takes 3.75 pounds of nitrogen per bushel of soybean grain. For 60 bushels, that's 250 pounds, and if we're looking at 100 bushel soybeans, that's 400 pounds of nitrogen needed per acre. The phosphorus, the potassium, the calcium aren't going to change too much because they're legumes, but the nitrogen actually will. So if we look at what we have in there as far as the inoculants providing some nitrogen, we're looking at probably 200 to 220 pounds of nitrogen being produced by the inoculation, and subtract that off. Even for 60 bushels of soybeans, we're still using potentially 50 pounds of extraneous nitrogen. For 80 bushels, be 125 pounds of nitrogen, and for 100 bushels, we'll still need another almost 200 pounds of additional nitrogen to achieve these yields. The phosphorus, the potassium, the calcium, we have for the phosphorus and potassium, that's straight phosphorus or straight potassium, not the P2O5 or the K2O. So this leaves us a couple lingering questions. Are our yield increases not being realized when pod set is greatly increased in the late summer because soybeans are not being adequately fertilized for this level of production? If so, then our fertility levels must be increased before any real conclusions about the products being tested can be reached. And I'll leave you with this parting thought. Biostimulants can increase potential yield, but they don't replace nutrition.